B?
Yeah, B number 4.
Very good. Oh, yes, of course. Very good. Yes. That's in 2.2. I do have my own form right here. And you said in 2.2, part B. Perfect. Here it is. The fifth root of 8 minus x squared. Use algebra to determine whether the following functions are even, odd, or none of the above. And this is b. So this is y equals the fifth root of 8 minus x squared. So we want to show or determine whether this is an odd, even, or none of the above. In other words, we want to determine whether this function is symmetric. Okay. What do I have to determine? We will also call this f of x because it's much easier to talk about f of x and y. It's the same thing.
F of x is the same as f of negative x. Negative f.
What do we have to calculate? Before we compare, what do we have to determine? What did we determine in the previous examples? What did we determine? Before I compare, I have to determine something. Before I look and compare, what am I calculating first? Mandatory. That's the first step. Let's go back to the lecture, because I emphasized it just a second ago. So let's take a look. Okay? So right here, what did I say? That we need to determine no matter what. Yes, but what do I have to calculate first before I compare, and before I decide if it is, if it isn't? You already answered when I said, do you see what is common in these two? What we have to determine, what we have to start with? What is common in these two? Yes, please. Correct. This is what we have to determine. That's the starting point.
Pretty sure that's what they were trying to say.
I'm sorry?
I'm pretty sure that's what they're trying to say.
They were saying to compare, but I haven't determined. Oh, okay. Did you say that? To find?
Yeah.
You said show that f of x equals f of negative x. This is not the answer, right?
Yes.
First, I have to determine. Exactly. Find f of negative x. I can't compare anything before I find f of negative x. Is that clear? Okay. So, what do I have to write? The fifth root, I have to calculate. Forget about the comparison. I have to determine f of negative x. I haven't determined it yet. So it's the fifth root of 8 minus, right, squared. Do you remember how to evaluate a function? Do you remember how to evaluate a function? So what does this function say to us? It says f of whatever is the fifth root of 8 minus whatever squared. So if I have f of whatever is the fifth root of 8 minus whatever squared, I have to calculate f of negative x. Is that clear? Okay. How much is negative x squared? Good. So this is the fifth root of 8 minus x squared. Only now I'm asking myself 3 questions. Not before I determine or calculate f of negative x. That's the starting point if I want to show symmetry algebraically. First step is calculate If you want to write it down, if maybe that wasn't clear last time, I apologize, my fault. You can write it down every time I'm asked to determine whether a function is symmetric or not. The very first step is determine f of negative x. I don't care what else steps I'm thinking of just yet. First, I need to determine f of negative x. Okay, so now I have 3 questions. The first question is, does this equal the original function? If it does, I will say the function is even and I'm done. Does this equal the opposite of f of x? Which you will say you haven't calculated it all. I'm going to calculate it right now. The 5th root of 8 minus x squared. If you say yes, then the function is odd. If none of the above happens, then the function is not symmetric. So, there is only one yes answer. Is it the first, is it the second, or the third? Right. So the function is even and we are done. The other 2 make no sense. Is this better? Perfect. Other questions here? Anything else from anything? Before we go back to the difference quotient. Yes, please. Marcus?
Just to make sure.
Yes.
What you were saying with the odd is that when you plug in negative x, it's the opposite of odd.
So let me give you an example. Okay, so here it is. Let's say I have g of x, which is x the square root of 1 minus x squared. Let's say this function is given to us. We're asked to determine whether it's symmetric, which means, in other words, if it's odd, even, or none of the above. What do I have to calculate first? Perfect. So let's calculate g of negative x. And what do I write?
Negative x.
Perfect.
1 minus negative x to square. Good.
Square root, very good. 1 minus negative x, everything squared. Do we agree with this? There is no need to put parentheses in front. It's not a mistake if you do. Okay, so obviously negative x squared is?
X squared.
So negative x, the square of 1 minus x squared. So only now I have 3 questions, right? Does this equal the original function, which is x, the square of 1 minus x squared? Does this equal the opposite of f of x, which is, if this is the function, the opposite will be negative x, the square of 1 minus x squared, or none of the above? There is only one yes answer and 2 no answers. So does this equal the original function? No. Does this equal the opposite of the original function? So I will say yes, so the function is odd, and the graph will be symmetric with respect to the origin. Does that clarify? Okay, very good.
So you're only changing the value of x, not everything else.
F of negative x is one quantity. The opposite of f of x is a different quantity. So once I'm done with f or g of negative x, then I have to compare it against the function, and I have to compare it against the opposite of the function. By opposite of the function, we mean we multiply both sides of the function by negative 1, right? So I multiply this by negative 1, which will be, oh, okay, it's g of x. Sorry. So I multiply both sides here by negative 1, and I get negative x, the square root of 1 minus x squared. Is that better? Okay, perfect. Do we need other examples? Do we need other examples? So that was from 2.2. And the next section is where it's going to be from 2.5, but we are not there yet. Would you like to try anything else from 4?
C.
Yes, C. Let's do C. Very good. Here's C. How are we doing with those factoring situations? Do you still have any questions on those? So g of t equals 8t to the 5th plus the cube root of 4t. Very good. We're asked to show whether this function is symmetric. What is the starting point? What do I have to do first?
G of negative t.
Very good. G of negative t, which means
Negative t to the 5th
in parentheses, yes,
plus
the cube root, or,
negative t.
very good. Now we have to simplify this. How much is negative t to the 5th power?
T to the 5th.
But it's an odd power.
That's negative.
Yes. When we raise a negative number to an odd power, we get a negative number, right? So it will be negative t to the 5th multiplied by 8, which is negative 8t to the 5th. How much is 4 times negative t? Negative t. But remember the cube root, so we have negative 4t under the cube root. The cube root can be rewritten as the cube root of negative 1 times the cube root of 4t. I can't take the cube root from 4t, but I can take the cube root from negative 1, which is? Which number I raised to the 3rd power to get negative 1? Negative 1. So this will be then negative the cube root of 4t. Before we compare, let's also determine negative g of t. Can anyone give us negative g of t? I'm multiplying both sides of the equation by negative 1. Very good, negative 8t to the 5th. If I distribute, I have to distribute everywhere. Yes? Cube root of 4t. Good. So now I have 3 questions to ask. Does this equal the original g of t? Does this equal the opposite of g of t? Or none of the above? If you say yes for the first one, it's even. If you say yes for the second one, it's odd. Which one is it? Or none of the above?
Odd.
Yes. This is not, it is indeed the odd. Why? Because this quantity equals this quantity. Since g of negative t equals negative g of t, this is the property specific to odd functions. Is that better? Okay, we will use this in chapter 3. It's very useful. Okay, now let's go back to the difference quotient. We did not finish this problem, and we need more problems, of course. Okay, so I'm just going to copy it again. So this is f of x equals x squared minus 5x plus 8. And the difference quotient was, again, in this class, you don't have to memorize it. It's easy, I think. It's f of x plus a little bit minus f of x divided by a little bit. That h, lowercase h, is a little bit. And I was saying then that this is given to us. It's right here. There's nothing I can do to it. This little bit nobody can change. So the only quantity that we did not have was this. Once I determine this quantity and I plug it in, I will be able to simplify, create the difference quotient and simplify it. And after we put this in here, I will tell you the what two things must happen for every difference quotient. Not yet. Okay, so this was our function, and we were asking, how do I determine this? Last time. That was our question. How do I determine f of x plus h?
X plus h for every x.
Perfect. That's all I needed you to say. Awesome. X plus h, everything squared, minus 5. X plus h plus 8. I need to simplify this fully before I put it in the quotient. So please tell me, what will I have to continue writing? And this is something we agreed on the first day of classes. Very careful.
X squared plus 2xh plus h squared.
Very good. And the rest is clear. No one can simplify this. This is done. Now, all this expression will come in here and replace this. And now let's put everything together. And then I will tell you which two things must happen. So the difference quotient for this function, can anyone dictate?
X squared
Perfect.
plus 2xh
Yes?
h squared
Yes?
minus 5x minus 5h plus 8.
Stop for 1 second. We are here now. Perfect. Minus?
X squared
Perfect.
minus 5x
No.
plus 8
Nope.
plus,
Nope. Yes.
uh,
Plus 5x.
minus 8.
Perfect. So when we distribute, we have to distribute to all terms. Awesome. Now, do we all agree with this step? Do we all see it? Okay. So now let me tell you two things that must happen for any function when we determine the difference quotient, or for any difference quotient for any function. Two things must happen. At the top, all terms without h must cancel out. If they don't, we have an error somewhere. One more time. At the top, all terms without h must disappear. It's a bonus if some of the terms with h disappear. That's fine. No problem there. But absolutely all terms without h must go away. After that happens, before we write the final answer, this h in the denominator must go away. There's still be left an h in the expression, in the final answer, but not this one from the denominator. So one more time, two things must happen. At the top, in the numerator, we have to get rid of all terms without h. If they don't cancel out, we have an error somewhere. The second thing that has to happen is the h in the denominator must go away. Okay, ready? So let's see. X squared, yes, goes away with negative x squared. Negative 5x, yes, goes away with 5x. Positive 8, yes, goes away with negative 8. How many terms are left?
3.
Good. What do they have in common?
H.
Let's pull it out. What is left at the top in parentheses, and how many terms?
2x plus h minus 5.
Do we all agree with 2x plus h minus 5? Good. What do you think I'm going to do next? Is the second thing that must happen.
Cancel.
Right. I can simplify the h with the h. Please write 1 so you don't think it's 0. So what is the final simplified form of the difference quotient for this function?
2x plus h minus 5.
What does this expression give? It gives a rate of change. The rate of change for this function between p and q. Okay, I think we need another. Would you agree? Okay, so let's choose another if you'd like to choose. If not, I will choose. And these problems are on page 252 from 71 through 92. 71 through 92 on 252. Please choose. If not, I will. Okay, I'm going to choose 83. Thank you for the vote of confidence. You wanted me to choose negative 2x squared plus 5x plus 7. Ready? We're asked to find and simplify the difference quotient. The difference quotient will be given to us, f of x plus h minus f of x divided by h. Which piece I do not have?
X plus h.
F of x plus h. Good. So I have this. This is just a letter. I can't do anything and simplify that. So I have to find f of x plus h. So let's find f of x plus h. What would you say?
Negative 2x squared plus 5x plus 7 plus h. Right?
Look at what the function is telling us. The function says negative 2 times blah squared plus 5 times blah plus 7.
Oh, okay.
I'm ready.
Okay. Negative 2x squared since our x squared, so that goes in x.
Very good. Thank you.
I don't see that this time. No.
F of blah is negative 2 times blah squared plus 5 times blah.
Okay, so we
Blah is x plus h. So I have to have x plus h. I have to have x plus h.
Gosh.
She's doing the extra
Yeah.
step.
Okay.
Extra step.
Okay. Okay. I see that.
So plus, very good, plus 7. So then negative 2. What about x plus h squared? What does it equal to?
X squared plus
Parentheses.
x squared
Perfect.
plus 2xh
Yes.
plus h squared.
Good. Plus 5x plus 5h plus 7. And now, only now I can distribute negative 2. We cannot distribute negative 2 before we square first. That's why I stopped. Is that clear? Perfect. So then, perfect.
Minus 4xh.
Very good. And plus 5x plus 5h plus 7. So now I can continue here, the difference quotient. What did we say? What are those two things that have to happen? All the terms without h at the top must go away, and eventually the h in the denominator must go away. There is an h left in the expression at the very end, but that's not the h from the denominator. It's a different one. I mean, it's the same letter, but not that particular one. Perfect. So can anyone dictate? This can be replaced by this. Has to be replaced by this. So negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h and plus 7. I reached this point right here. I'm right here. What now?
So it's gonna be plus
Perfect.
2x squared
Yes?
minus 5x
Perfect.
minus 7.
Awesome. Divided by h. We know what has to happen. Let's see if we made any error. I see a negative 2x squared with a positive 2x squared. Agreed? I see a positive 5x with a negative 5x. Agreed? And I see a positive 7 with a negative 7. Now, how many terms are left? What is common to all three? Very good. It must be, because at the end of the day, I have to remove that h. Now, carefully, what is left up?
Negative 4x
I agree.
minus 2h
I completely agree.
plus 5h
Perfect. Nope.
plus 5.
Correct. Yes. So we got rid of the h, top and bottom, by simplifying. What is the simplified form of the difference quotient? Any questions here? Danielle, are you okay? Any questions? H times negative 4xh, h times negative 2h, and h times positive 5. Is that okay? Everyone? Yes? Okay, so the answer is? Very good. Plus 5. Perfect. That's what it is. Did we get the idea? Do we need another difference quotient? Or this is good enough? Is it good enough? Okay. So one other topic before we move on to review 2.3 and 2.4. But we'll do everything. But one other idea, or topic I should say, is what is called the piecewise defined function. Piecewise defined function. Piecewise defined function. Okay. I'm going to select a problem. We are still on page 252. I don't like any of them, but I am going to select 69 on 252. And f of x equals 0 if x is less than negative 4, negative x if x is between negative 4 and 0, and x squared if x is greater than or equal to 0. Okay, why do you think this function is called piecewise? Because it is defined using 3 pieces. However, those 3 pieces do not overlap, do not go one over the other. So in the first interval, I have a function which does not go to the left of negative 4. In the middle, I have another function that is defined between negative 4 and 0. And then to your right, I have another function that is defined between 0 and infinity. These functions don't go one over the other. The first one is only on this interval, the middle one is only on this interval, and the last one is only on this interval. Okay, so please don't graph something like this. This is not a function. You cannot extend a function that is defined only on one piece to the over the other pieces. Is that clear? We'll see in a moment. Okay, what do I have to do? Here's the question is, graph it. Graph it. What is my first thought? Anytime I need or I'm asked to graph a function, my very first thought.
What kind of function is this?
Correct? Well, we answered that. Awesome. Very good. That's the very first thought. It's a piecewise defined function. What type of function will this be? Well, it's linear. What type of function will this be? It's perfect. What type of function will this be? Perfect. Awesome. Good. So what is my next thought? Once I identify the function, what is my next thought? Always. It starts with D, as in dog. Exactly. I have to find the domain. Good. So I'm looking at this interval, and I would say, okay, in interval notation, that's why I insist on the interval notation. In interval notation, how will I write this? This is not the domain of the function, but I have to look at each piece separately. So how do I write this in interval notation?
X and negative infinity.
Very good. To negative 4. Very good. Awesome. We agree with this? And you can say, why are you changing this? Why are you solving this? And I'll show in a minute. Okay. What about this? What will this interval be?
-4 to 0.
Perfect. What do I have here?
Brackets.
Awesome. What do I have here? Awesome. I need one more. Infinity is always a parenthesis, and here, awesome. Very good. So now let's analyze these three pieces, because the domain belongs to this. This is the domain for this one, this is the domain for this one, this is the domain for this one, but we are really interested in the domain of the function f. Okay, so I see we have everything between negative infinity and -4. Okay, we do have -4 and everything between -4 and 0. We do have 0 and everything between 0 and infinity. So then I would like to conclude, what is the domain of this function? Do we all agree with that? Nothing is missing. So this function is defined on all real numbers. Very good. Oops. Therefore, I will start my table, and f of x. I will put negative infinity to infinity. Which x values I have to have in the table, no matter what? What do you think? Look at the different pieces. And
-4 and 0.
absolutely, thank you very much. Awesome. -4 and 0 must be in the table. Other x values as well, but definitely -4 and 0. Why? Because at -4, something very important happens. This function changes from this to this. At 0, also something very important happens. The function changes from this to this. So we call those like thresholds, right? Okay, good. Next, look at -4. There is a parenthesis facing this way. Right under -4, I'm going to draw a parenthesis exactly how this one is facing. On the other side of -4, what will I have to graph? And they are touching. Both symbols right under -4. Not to the left, not to the right, immediately under -4. Okay, I know you haven't seen this yet, and you don't understand probably why I'm doing this, but you will. It's going to be very easy. I would like you to tell me what symbols I have to write under 0. Exactly, because there is a parenthesis facing left and a bracket facing right. Awesome, and they are touching. Here's my next question. I know I have everything under my nose right here, but it's safer to write it under on top of the table. Which function will I be using between -infinity and -4? For x values between -infinity and -4, I will be using which function? We have 0. Which function will I be using for x between -4 and 0? Very good, awesome. And now which function will I be using between 0 and infinity? You can say, this is silly. Why are you writing this again? I see them right here. Here's the reason why I'm writing them again. It's because sometimes these may be not in this correct order, and I may make a mistake and plug in something somewhere where I shouldn't plug it in. Okay, good. Here's our next step. I need, for a linear function, how many points I need to plot? Exactly how many? Exactly 2. Awesome. So a number, can you give me a value of x to the left of -4? Good. When x is -5, how much is y? Plug it in. Perfect. There is nothing to plug it in. Good. So now plug in -4. But you should say no. You cannot plug in -4. -4 is not in the first branch. I'm still going to ask you to plug it in, and you'll see in a moment why. Please plug it in. What do I get? Right here in the middle of the parenthesis, right in here. What do I write? Perfect. Right here inside parenthesis. Stay with me. Now I'm on the other side. Please plug in -4.
4x.
No, just 4.
Oh.
X is -4, correct? Good. So right here inside the bracket, I wrote 4. Now please plug in 0, and you should say the same thing. No, 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 no. So we'll bear with me and plug in 0.
0.
Perfect. On the other side, please plug in 0. 0. And let's look at one other. We should determine more than one, but that's okay. We know this function already. I don't want to plot 25. So let's say 2, 4. I mean, I can. It's not a mistake or anything. Good. Ready? Okay. So let's graph this function. What is the first ordered pair from left to right? Now I don't even know what colors to use. They may disappear. The graph may not show. What function value, what ordered pair do I have to start with? Mandatory.
-5 is 0.
1, 2, 3, 4, 5. Perfect. Next ordered pair.
-4 and 0.
Correct. Now let's look at this point. Is this point going to be a full point or an open point? Correct. So this is the first branch. We're done, and you can forget about the first one. Okay. The next ordered pair in line.
-5.
Is this a full point or an open point? Yes, because of the bracket. The next ordered pair, please.
0, 0.
Is this going to be a full point or an open point? This is a straight line, and this is the piece. No one can extend this to the left or to the right. This is it. We're done with the second piece. We can forget about the first and the second. Now I'm continuing with the third one. What is the next ordered pair that I have to plot?
0 and 0.
Is it a full point? Perfect. And then 2, 4. But now this is not a straight line. This is a quadratic function. We're going to talk about these functions in chapter 3. It will be the first section of chapter 3. I'm going to ask you now, what is the range of this function?
0 to
Very good. From the lowest y value to the largest y value. Do we understand? We're going to choose another problem in a minute. But do we understand why? Do you see now why I changed the inequalities into interval notation so I can identify what symbols I need underneath, both -4 and 0, so I know which one will be an open point and which one will be a closed point. That's the reason I did that. And yes, you should have been appalled, like I'm sure you are, when I said plug in -4 here, or I said plug in 0 here. But if I don't plug in 0 in here, then I have to plug in the smallest number to the left of 0, like -0.00000000, because otherwise I miss an infinite number of ordered pairs. So that's why instead of doing this, I prefer forcing the 0, but I will have to remember that it's an open point. Because these two numbers are the same, it turned out that this point is not an open point, because this number and this number were the same. On this side, this number is 0, and this number is 4, so this is called a jump. The function jumps. This is non-existent. It's an empty point, and this is a full point. This is how we graph piecewise defined functions. Can anyone give us an example of a piecewise defined function from real life? I know nothing about the new tax code, but I know that in the past, the formula, and I think you can tell us more about it, right? So I'm making up numbers, so you can correct me, please. So for a certain income bracket, there was a certain percentage. That's a piecewise defined function. Certain percentage that people have to pay as income tax. For the next bracket, it's another percentage. For the next bracket of income, another percentage. So that's a piecewise defined function. It's also a step function. Here's another example. In the past, some of us did not have infinite or unlimited number of minutes, cell phone plan, right? So I'm making up numbers. If we talk between 0 and 1,000, we pay $25. If we talk between 1,000 and 2,000, we pay $30. And this is another step function. Okay? So let's choose another. Feel free to choose one if you would like.
We do one that's backwards. What do we like?
When you say backwards, you mean
We have the graph. We have to determine. Three functions.
So they're not arranged in the correct order, you mean?
No, I mean, we don't have f of x, but we have the graph. We have to determine f of x.
Oh, that's a good question. I don't know if I can come up with one like that. Did you see one like that? I would love to work with you.
Just curious first.
No, not really. Not really. But if you find one, I'll be honored. I can make one up. But if you had one, it will even be easier. So I can make one up if you want. It's a good point. Very good. Perfect. So how many pieces does this piecewise defined function have? 3 pieces. Let's establish the ifs first. Very good point. So let's establish the ifs first. If what? What is the first domain? Bless you?
It's like if x is less than -3.
Perfect. Good. Let's establish the if in the middle. If you want, I don't have to make it continuous everywhere. I can adjust the graph. That's even better if you want. You want to continue, you want to define on all your numbers or not? You want to see a gap?
Yeah.
Okay. So I'm going to delete this. And I'm going to start here. Good. So the second branch.
So x is greater than -1, and that's 1, right?
Perfect. Yes. And the last one?
X is greater than 1.
Because it exists. Yeah. Very good. We can determine the middle piece with no problems right away.
Negative infinity to -3. What are we doing? So points?
4. Very good. So the function is 4 for any x values between -1 and 1. Is that clear? The function values 4 for any vex value between -1 and 1. Perfect. So now, you know, and this is very good because this is what I'm going to do in 2.3 and 2.4. Obviously, this is a linear function, right? Okay, so this is definitely a point that is very clear to identify, right? -4, 0. And this is also a very clear point, which is -3, comma. So I need to determine the equation of this line. I do have 2 points. This is a line segment, I mean a function that is a linear function. How do I determine the equation?
X squared, M squared.
I have to find the slope first because it's a line. And that is y2 minus y1 over x2 minus x1. So this is my first point, this is my second point. What would you write? Meaning this is x1, y1, and this is x2, y2.
Minus 0.
Very good. -3 minus 4. The top is 2, the bottom is 1, so the slope is 2. Good. So now, if you remember, we do have 2 different equations of the line. We have y equals mx plus b, which is slope intercept form, which is slope y-intercept form, remember, not x. And the other one is y minus y1 equals the slope times x minus x1, which is point slope form. Okay, which one